Good morning, students. In this video, we are going to discuss about the next topic of addressing modes, module 2, stacks, queues, and subroutines. Let's first discuss about stacks and queues, then move on to the subroutine. What do you mean by a stack? A stack is a special type of data structure where the elements are inserted from one end and the elements are deleted from the same end. This end is going to be called as a top of the stack. Various operations can be performed on the stack, maybe insertion and deletion. The stack, which is going to be generally called as or the working can be explained as last in first out, LIFO. The last data which is going to be inserted can be easily removed only at the first. So that's why it's going to be called as last in first out. So here two operations are going to be there, the insertion and deletion. Insertion is going to be called as push operation, deletion is going to be called as pop operation. An element which is inserted from the top end, insertion operation, which is going to be called as push operation, push into the stack. An element is deleted from the top end, the deletion operation, which is going to be called as pop operation, pop from the stack. A process register is used to keep track of the address of the element of the stack that is at the top of at any given time. This register is going to be called as stack pointer, SP. If we assume a byte addressable memory with a 32-bit word length, the push operation can be implemented as subtract asterisk 4 SP move new item. The pop operation can be made like that. Just we will have an example of this particular operation. This is nothing but the stack bottom, the bottom of the stack. This is a stack bottom, and the data are going to get stored from bottom like this. It goes on over there, where the last data which is going to be present over there, that is going to be called as a current top of the stack, that is called as TOS, top of the stack. So the stack pointer is always it's going to locate the top of the stack, that is going to be called a stack pointer. This is going to work as last in first out operation, which was called as LIFO. Let's have sometimes the stack may be full or sometimes the stack may be empty. So we will have two example, as I said, push and pop. Let's see about that one. When it's going to push, obviously what happened, the stack pointer which is going to be keep decrementing the stack, and which is going to be increment the top to the next one. When which is going to be have a data, the data is going to get stored over there in the particular location. Then we can say that the stack is going to be full minus 1 and the empty becomes 0. As like that, the pop operation, when the pop operation is going to be there, the last data which have been inserted, that's going to be removed from that one. Then the stack pointer is going to be moving plus 1 and it's going to be increment towards the next. There's nothing but it's going to move the next data where it's going to get stored over there from 5 to 6. Then the sixth position is going to be shown as a top of the stack. Such a way it's going to do that. Now empty will become minus 1 and full becomes plus. Such a way it's going to make the operation. The stack organization, which can be seen in a different way. It may be a memory stack, it may be push instructions or a pop instructions. The stack operation can be easily understood by using a reverse Polish notation. How, in the sense, infix notations, a plus b, prefix or Polish notation plus ab, then postfix or reverse Polish notation, RPN, that is going to be called as ab plus. Usually the stack operation is going to be always work under reverse Polish notation. So example I have given over there, a into b plus c into d. How the reverse Polish notation is going to be happen, or is going to be get work over there. With an example we can do that one. So it becomes a b into c d into plus. Such a way the symbolic rotation is going to be notation is going to be represented as RPM. Take an example of this. Instead of ABC, I am going to take a data as 2 4 into 3 3 into plus. There is nothing but 2 into 4 plus 3 into 3. How this is going to be work over there? It's going to do the data of, first it's going to take the data of 2 into 4 as 8. Then it's going to do 3 into 3 asterisk plus will be present over there. Now it becomes next data 3 into 3 will become 9, then 8 plus 9, which is going to be made as data 17. Such a way that the stack is going to get operated over there. With another example, we can see about the particular operation. A plus B, the operation is going to become A, B plus, then it takes the next data as D plus E, because always the plus notation will become the first one. Then it moves towards the C toward that side. Then it moves the data of F into that one. Such a way it's going to do the notation. Finally, it becomes the asterisk value. So the stack operation can be understood by the example how the stack is going to be storing the data into the stack by having this insertion of the data with pop instruction. We will see about that one. Now push 3 has been pushed, so stack pointer is going to be identifying the data. Then push 4, now the data has been incremented, so the stop of the stack is going to be pushed to the next level. When multiplication, so multiplication is nothing but both the data will be multiplied and the data will be replaced with that, so it becomes the 12, and the stack pointer always identifies the 12 value over there. Next push 5, stack pointer incremented, then push 6, stack pointer again incremented, then multiplication of 5 and 6 will be operated over there, so it's going to do 30. Now 12 plus 30 becomes additive plus, so add, obviously what happened, it removes the data and finally it adds the data as 42, and that is going to be stored in the particular stack pointer. So there the stack pointer is going to be identifying the or pointing the particular value. Such a way this reverse Polish notation is going to be work in the stack operation. So coming to the next one, queue. Data are stored in and retrieved from a queue on a first in first out basis. So it's nothing but just like stack, it's going to do first in first out. So the diagram which has been shown over there, it's going to enter the data toward this side and it's going to move to the next position, and finally the first in data is going to be the first out data. So NQ is going to be made over here. This is nothing but the rear end. So here it's going to enter into that one, and first front end it's going to come out. That is going to be called as DQ. So insertion and deletion happens on different ends in this particular queue. This is going to be called as a queue operation. So data are stored and retrieved from a queue on the basis of first in first out. Okay, this is an operation of a queue. Let's see about a difference between stack and queue. Stack is going to be in such a way, it's going to be from top to bottom or bottom to top, whereas queue is nothing but from left to right operation. So it's going to do this. This is a basic difference between stack and queue. In generally, objects are inserted and removed at the same end in the stack, whereas objects are inserted and moved from different ends in the queue. The second one, in stack only one pointer is used in the top of the stack, whereas in the queue two different pointers are used from front end one pointer and rear end another pointer. And the stack, the last inserted object is the first outcome, whereas in this queue the object inserted first is the first outcome. Stack follows last in first out order, whereas queue follows first in first out order. Stack operations are push and pull, whereas queue operations are NQ and DQ. Stacks are visualized as vertical collections, whereas queues are visualized as horizontal collections. Collection of dinner plates at a wedding reception is an example of a stack, whereas people standing in a file to board a bus in an example of a queue. This is the difference between stack and queue. Now we are going to move on the next topic called as